Have you ever wondered what an impact crater looks like from space? Craters are inevitably part of being a rocky planet. They occur on every planetary body in our solar system, no matter the size. By studying impact craters and the meteorites that cause them, we can learn more about the processes and geology that shape our entire solar system. Over the past 2 decades, ESA has tracked and analyzed asteroids that travel close to Earth. ESA's Fly-Eye telescopes will survey the sky for these near-Earth objects, using a unique compound eye design to capture wide-field images. This will enhance the detection of potentially hazardous asteroids. ESA's HERA spacecraft, launching later this year, will closely explore asteroids and improve our understanding of these celestial bodies. This will help us better prepare for potential future asteroid deflection efforts. Today, for Asteroid Day, we're counting down some of our favorite impact craters here on Earth, captured by satellites. Number 10. Nordlinger Ries. Formed around 15 million years ago, Germany's Ries crater didn't become apparent until the 1960s. Prior to that time, many geologists had suspected that the crater had been formed by volcanic activity. The crater's rim can be seen as a semicircle. The medieval town of Nordlingen was built in its depression. The impact led to the creation of over 70,000 tons of microscopic diamonds. The stone buildings of the town were constructed almost entirely with diamond-encrusted rock. Number 9. Oaxis Crater. The Oaxis impact crater is located in northwest Algeria, close to the border with Morocco. Around 3.5 kilometers across, the crater was created when a meteor hit Earth less than 70 million years ago, when dinosaurs still roamed the planet. Originally called Tinduf, the crater is now heavily eroded. Despite this, its circular shape still remains evident due to the exposure of ancient sedimentary rock layers, which create ridgelines that run roughly northwest to southeast. Number 8. Tanuma Crater. Deep within the Sahara Desert lies one of the best preserved craters on Earth. It was long debated whether the Tanuma crater was formed by a volcano or meteorite. Scattered rocks around the crater created the impression of an ancient volcano. But a closer examination of the structure revealed the crater's hardened lava was actually rock that had melted by a meteorite impact. Tanuma crater is almost 2 kilometers wide. The rims rise over 100 meters high above the base, but the bottom of the crater is covered with a thick layer of sediments. The crater sits in a vast plain of rocks that are so ancient they were deposited hundreds of millions of years before the first dinosaurs walked Earth. Even though it resides in ancient rock, Tanuma is much younger, ranging in age between 10,000 and 30,000 years old. Number 7. Gosses Bluff. The Gosses Bluff crater in the Northern Territory of Australia was most likely formed 140 million years ago by the impact of a large comet or meteorite slamming into Earth. It is one of the most studied of the Australian impact craters. Australia is a very good place to observe and study impact craters. Because of the dry climate, the craters haven't weathered away, nor are they hidden by dense vegetation. Number 6. Silurian Ring. Around 400 million years ago, an asteroid slammed into the land that is now south-central Sweden. Its impact left quite a mark. After millions of years of erosion, the scar it left is still recognizable, especially from above. Measuring more than 50 kilometers across, the Silurian Ring is the largest known impact crater in Europe. It is surrounded by a depression, which today is partially filled with water. Number 5. Rotterdam. The Rotterdam impact crater is found in the Namib Desert in southwest Namibia. According to geologists, the crater was formed by a meteorite around the size of a large vehicle that collided with Earth around 5 million years ago. The crater is around 2.5 kilometers wide and is around 130 meters deep. It is clearly visible in contrast with the Rest Red Dunes, with its rims rising over 50 meters above the surrounding plain. Number 4. Manicouagan Crater. In southeast Quebec lies one of the world's oldest impact craters. The Manicouagan crater was formed 214 million years ago when an asteroid 5 kilometers wide struck what is now Canada. Its concentric structure results from the shock waves transmitted by the impact. The structure is around 100 kilometers across, with its 70-kilometer diameter ring its most prominent feature. Number 3. Shoemaker Crater. Formerly known as Teague Ring, the Shoemaker Impact Crater is located in Western Australia and was named after Eugene Shoemaker, a planetary geologist and pioneer in impact crater studies. The almost circular shape of the Shoemaker impact site is around 30 kilometers in diameter and is defined by concentric rings formed in the sedimentary rocks, seen in dark brown. The precise age of the impact is unknown, but estimated to be around 1.6 billion years old. Number 2. Airunga Crater. The Airunga Crater in northern Chad is one of the best preserved impact structures in the world. It was thought to be created by a meteorite impact around 340 million years ago, based on the age of sedimentary rocks deformed by the impact. The central highland, or peak of the crater, is surrounded by a sand-filled ring, which is also surrounded by another ring of rock. The linear rock ridges that run diagonally are yardangs and are formed by wind erosion. Here we can clearly see how the wind blows from northeast to southwest. Number 1. Meteor Crater. The Meteor Crater, also known as Barringer Crater, is located in the desert of northern Arizona. It's around 1,200 meters in diameter and 180 meters deep, surrounded by a rim of smashed and jumbled rocks, some the size of small houses. One of its main features is its squared-off outline, believed to be caused by cracks in the strata at the impact site. Discovered in 1891, the crater's age has been variously estimated to be around 50,000 years old. The crater is a site of active research. It is well preserved, making it an excellent place to learn about the process of impact cratering. Thanks for watching. Let us know in the comments below which impact craters you'd like to see from space. Until the next time.